All right, let's complete the square to convert forms of a circle. So what we don't like about this form of a circle, it's hard to tell where the center of this circle is. It's hard to tell where the radius is. So we're going to use the process known as completing the square to convert this to a more convenient form. The way I'm going to do that is first I'm going to group all my variables together. I'm going to get x squared minus 8x. I like to leave a little bit of space because we're going to add some additional information into this row. To that, we will add our y terms, y squared and 10y. Again, I'm going to leave a little bit of space. And I'm also going to move my negative 23 to the other side of the equation. What I'm trying to create here is perfect trinomial squares. In order to do that, I need to identify my linear term, in this case, the negative 8x. I'm going to divide it in half and square it. So negative 8 divided by 2 is negative 4. Negative 4 squared gets us to 16. So what we're going to do is we're going to add 16 into our equation on the left-hand side. And in order to keep this equation consistent, we are also going to add that 16 to the other side of our equation. I'm going to follow that same process. I'm going to take 10, my linear term for the y variable, cut it in half and square it, and I will end up adding 25 in that part of the equation. And again, I must include an additional 25 on the other side of the equation as well. So it seems like we just introduced all these new numbers into the problem, but it was all with a purpose. What this allows us to do, it allows us to factor each of these trinomials into their perfect trinomial squares. I know that if I were to factor the blue terms here, I could write that as x minus 4 times x minus 4, or x minus 4 quantity squared. And I can do the same thing with my y terms into y plus 5 quantity squared. And then I just need to combine all my terms on the right-hand side of my equation. I end up with 48 plus 16 is the way I see it, and we'll end up at 64. This will be a circle whose center is at the point 4, negative 5, and whose radius is 8. In this form, what we've converted to right here, those details are much easier to see, which is why we like to complete the square when we're dealing with circles.